All right, this is the last topic in Chapter 6, proving that a quadrilateral with given vertices is a parallelogram, meaning that opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. So we're going to prove that, and there's different methods to do so. So we're going to use Alex's help in figuring out which method they want us to use. So they're going to kind of guide us through which method we're going to use to determine this. So our first box here, A, we're going to want to complete this. It says find the length of QR and the length of PS. Give exact answers, not decimal approximations. So when we're finding the lengths, we can either count them if it's a vertical or a horizontal line on the grid. And if it's a diagonal line, we're going to have to use the distance formula. So the distance formula, which I have up here, distance and midpoint formula, I'm going to grab those down, slide those down here. The distance formula has a square root symbol that it uses. We're going to take the square root of some number, and you guys know that sometimes that number is a decimal. So if that's the case, we're going to instead just simplify the inside and leave our answer with that radical symbol. Okay? So we're going to have to use the distance formula, and they want us to first find QR, and then we're going to find PS. So QR and PS. And we're using the distance formula to see if they're the same length. Okay? In order to use the distance formula, we need the coordinates, which they give us right here. So that's nice. I'll do PS first since I circled P. And we know that we can label these x1, y1, x2, y2. Okay, and then plug them into my formula. So I'm going to start off square root, parenthesis, x2 is -6 minus x1, which is a -3. And notice I have two minus signs there. Some teachers like you guys to automatically change that to a plus sign. I don't mind if you leave it. Just make sure you type it in your calculator with two minus signs. Okay, plus y2, which is this number 4 here. 4 minus y1, which is again another negative, so -1 squared. And like I said, some people like to just change those to pluses. So their next step might be -6 plus 3 squared plus 4 plus 1 squared. Okay, and then you can type that whole thing into your calculator if you have one that does square roots. See if you get a nice number. So that's what I'm going to do. I downloaded a scientific calculator on my phone. So -6 plus 3 squared plus 4 plus 1 squared. And I don't get a nice number. I get 5.83. So what I'm going to want to do instead is just simplify this stuff in the middle. So I'm going to do the same exact thing except for take off the square root. So I'm going to do everything but that square root. And I get 34. So I get 34 under here, so square root of 34. Okay, so what they mean by not decimal approximations is they want us to put in that square root number instead. And again, I got that by just typing in the -6 plus 3 squared plus 4 plus 1 squared into my calculator instead of adding that square root. I just left that off and added it to the end. Okay, So I'm going to erase that work here and start on finding QR. So we're finding QR next. Okay, I'm going to start by labeling x1, y1, x2, y2. Start with my square root here. And then I'm going to do -1 minus 2 squared plus y2 is 8 minus y1, which is 3 squared. And again, we would start off by just typing that whole thing in. And so this takes just a couple seconds here. So -1 minus 2 squared plus 8 minus 3 squared. Oh, we get another decimal answer, 5.83. Oh, it's the same decimal answer as I got last time. So I know they're actually going to be the same. So I'm not going to even have to type in this part without the square root. I just know it's going to be 34. So I'm going to write in there square root of 34. Okay, so it looks like these two lengths are congruent. Let's see what it wants us to do next for part B. Find the slope of QR and the slope of PS. Okay, so we didn't actually have to use the midpoint formula here, but you might, so you may want to write that down. I know a lot of you guys have it in your notebooks if you're in my class. You can Google it real quick, doesn't take too long. So we're finding the slope of these same two lines. I'm going to zoom in here a little bit because I'm going to find the slope. There is a slope formula, but I'm going to find the slope by using the graph. Okay, so what you want to do when you take this approach is I like to draw what's called a slope triangle. So I'm going to go either up or down. So starting at my left point, which in QR, that would be the point R. R is to the left of Q. And then I have to go down to get to Q and to the right. So this slope is going to be negative. If you're going down from left to right, it's a negative slope. And then I'm just going to count from R down. 1, 2, 3, 4, 5. So this was a 5 right here. Then I'm going to count over to Q. 1, 2, 3. So my slope for RQ is -5 over 3. And then I'm going to find the slope of PS. So starting at S, because that's to the left of P. Oops, I went down a little bit too far. Change my color here. Down and to the right. So then I'm going to count again. 1, 2, 3, 4, 5. And 1, 2, 3. And this is also negative. We're going down. So -5 over 3. Okay, so let's just mark on our picture what we know. I know that they have the same slope, which hopefully you guys remember means that they're parallel. And I also know that they are the same length. So they are parallel and congruent. Now, if you guys remember from chapter 6, when we had all the ways to prove parallelograms are a quadrilateral is a parallelogram. This was method 6. That was our last method that we looked at, where one pair of opposite sides are congruent and parallel. So let's go down and fill out the rest of the information that we need. So the slope of QR was -5/3. PS was -5/3 as well. So from parts A and B, what can we conclude? The quadrilateral is a parallelogram because it has one pair of opposite sides, both congruent and parallel. Yes, that is exactly what I just said. But let's read through the rest of them and figure out why those are not correct. says the quadrilateral is a parallelogram because it has one pair of opposite sides that are parallel, even though those sides are not congruent. Well, no, we know that the sides are congruent. So that's why that one would be wrong. This next one, it is a parallelogram because it has one pair of opposite sides that are congruent even though the sides are not parallel. Well, that is wrong. The sides are parallel. And this is wrong because it is a parallelogram and it can be determined that it's a parallelogram. Okay, so it's always good, especially if your first one you think is right, read through the other ones because maybe they had put this one first and you're like, well, it is a parallelogram, I'm not really sure. But just read through all of your choices, okay? You don't want to get this one wrong after doing all that work because you select the wrong bubble. That can be frustrating. All right, so they may have different ways, different A's and B's to get you to determine if it's a parallelogram. So just be looking out for what do they want you to do in that first box, what do they want you to do in the second box. Based off of those two answers, what can you conclude? Okay, that is it for chapter 6. If you have any questions, let us know and we can meet with you one-on-one or do some more videos on other problems that you're coming up with if this one isn't on there.